Hello viewer, thank you for coming back to watch this video tutorial on my channel. Now, if you are new, kindly subscribe to my channel and refer to your friend. Otherwise, we can start. This paper was examined in the year 2024, January, as Mechanics 1, and this question 7. The first instruction is always as given. In this question, I and J are unit vectors directed due east and due north, respectively, and the portion vectors are given relative to a fixed origin O. At midnight, the ship was at a point with position vector. That is OS. That is actually OS. The displacement of the ship from the origin. The ship travels with a constant velocity of 12I minus 16J. Find the speed of S. So speed is normally given as the modulus of the velocity vector, and the velocity vector has been provided for us here, so we can actually get the square root of the square of the I component plus the square of the J component. This is giving us the square root of 400, which is basically 20 kilometers per hour. Now at time t hours after midnight, the portion vector of S is S kilometers. Find the expression for S in terms of ij and t. Just know that initially the ship was at 1922, and then the ship after t hours is going to displace, so we are going to have our constant velocity, which is a 12I minus 16J multiplied by time, and this is going to give us S equals to 19 plus 12t I, then plus 22 minus 16t j, and that's the answer for the second part. And then finally, we are told that a lighthouse stands on a small rocky island. The island is modeled as being a point with the portion vector 26 I plus 15j. It's not safe for the ship to be within 1.3 kilometers of the lighthouse. Find the value of t for which S is closest to the lighthouse. This is a good question. We are solving C Roman 1. Now let's have a look at the following observation. What's the displacement of the ship from the lighthouse? So this is the same as the displacement of the lighthouse minus displacement of the ship from the origin. Displacement of the lighthouse from the origin, it's already given in the question. So this is a 26I plus 15J minus the displacement of the ship from the lighthouse at any given time. It's this value that we obtained over there, which is 19 plus 12t I, then 22 minus 16t j. So when you work this one out, we are going to end up having 7 minus 12t, then negative 7 plus 16t. Now, if that is the displacement of the ship from the lighthouse, we will be able to get the distance between the ship and the lighthouse, which is going to be the square root of 7 minus 12t squared plus negative 7 plus 16t squared. So when you work out this, it does give you the expression. This is 49 minus 168t, then plus 144 t squared, then plus 49, then minus 224t, then plus 256 t squared. So this is our SL. Yes. Now we can square on both sides to remove the square root. Then we are able to get SL squared as 98 minus 392t, then plus 400 t squared. When you simplify that, that's what you're going to get. Now what happens? We need to get, okay, let's answer this question. What time minimize the distance between the lighthouse and the ship. So this is easy. So we are going to differentiate this and equate it to 0 and look for t. So this will be d SL squared divided by dt, which is going to give you negative 392 plus 800 t. Now equating this one to 0, we are going to have 800 t minus 392 is equal to 0, and therefore 800 t equals to 392. This gives us ts 0.49. So this is the time that's going to minimize the distance between the lighthouse and the ship. Now we are told that it's not safe for the ships to be within 1.3 kilometers of the lighthouse, so we need to determine whether it's safe for the ship as to continue to its course. So what we need to do for this Roman 2, we can get the exact distance. So we know SL squared, this distance squared is given by, we already have 98 minus 392 t, then plus 400 t squared. So substituting t inside, it's going to give us 98 minus 392 into bracket 0.49, then plus 400 into 0.49 squared. So this is SL squared. So our SL squared is going to be 1.96. So square rooting on both sides gives us SL as 1.4 kilometers. Now we are now getting the distance between the ship and the lighthouse as 1.4 kilometers. So since 1.4 kilometers is bigger than 1.3 kilometers, you can say it is therefore safe for the ship to proceed to its course. Thank you, and that was the solution. Please remember to share it with your friends. You can drop a comment in the comment box to get the feedback as to how the lessons are and how you're faring on. Otherwise, good luck for your exams and have a nice time.